Hello everyone, my name is Aisha Chiandet, water scientist with the SSEA, and I'm going to give an overview on climate trends that SSEA has been observing in the Severn Sound area through our climate and water quality monitoring programs, and also trends using more regional data sets. I'll first discuss climate drivers that impact lakes, namely air temperature and its corresponding influence on water temperature, wind speed, and precipitation. These can operate at both local scales like the Severn Sound watershed level and more regional scales like the entire Great Lakes Basin. Using rainfall as an example, we can look at the trends affecting just the southern Georgian Bay area that may impact water quality, but also need to take into account what's happening across the whole Great Lakes Basin when looking at something like water levels. The second part of my talk will deal with the impacts of climate drivers on ice cover, algae growth, and water levels. I'll be focusing mostly on Severn Sound, although many of the trends that are occurring also occur widely across Georgian Bay. For each driver and impact, I'll touch on local and regional trends, implications for change, and forecasted trends based on modeled climate projections. Just to get you oriented, Severn Sound is a collection of bays in the southeast corner of Georgian Bay, and the watershed covers township of Tiny over to Aurelia, up into Honey Harbor, and south to around Elmville. The water temperature, nutrient, and algae data I'll be showing was collected from 5 long-term monitoring stations in Severn Sound, which are shown in the large red circles. We collected data at all of the sites shown here, but our long-term sites have data going back to the late 60s or early 70s, which gives us a much better data set to look at trends. Sites are monitored each year during the ice-free season from May to October and are sampled every 2 weeks. So let's jump right in and start with temperature. Many folks are probably aware that air temperature across the region is increasing, and you can see that on the top graph as the change from the long-term average in Ontario. In Severn Sound, our long-term monitoring data, shown on the lower graph, indicates that surface waters have been warming at a rate of about 0.4 degrees Celsius per decade. When we look at October water temperatures, that rate of warming doubles to nearly 0.9 degrees Celsius per decade. This fall temperature increase can fuel late-season algae growth and can delay ice formation. Warmer temperatures across the entire season can result in earlier ice off and leads to more growing days and longer window for algae blooms to occur. Climate models using the business as usual scenario, or RCP 8.5, project air temperatures in the region to increase, so we expect these trends in water temperature to continue. Wind speed is a difficult variable to look at trends for, partly due to inconsistencies in historical datasets, but a study in 2010 that combined wind data from Environment and Climate Change Canada weather stations across Ontario showed that average wind speeds are decreasing, as you can see in the lower graph. This has the effect of making surface waters calmer and warmer, which can favor algae growth, particularly blue-green algae. You might think that it seems windier in recent years, and we have seen an increase in storm events and associated strong winds, which are interspersed among calm periods. These strong wind events cause short-term water level fluctuations, known as seiches, that can lead to coastal flooding and erosion, especially in combination with high water levels. The top graph shows wind speed from the Western Islands as the black line and the corresponding effect on water levels at 4 locations in southern Georgian Bay as the colored lines, and you can see there is a bit of a lag effect there. Wind-driven mixing in shallow waters can cause sediments and nutrients to get stirred up, adding fuel for algae growth. The projection is for average wind speeds to continue to decline, but for the frequency of intense storms to rise. Precipitation is highly variable from location to location, but we know that on a Great Lakes Basin scale, there is a general increasing trend. Fluctuations from year to year have an impact on water level changes. We know that we're seeing more frequent and more intense storm events that bring pulses of nutrients into water bodies, which are interspersed by calm, dry periods. These conditions favor algae growth, and particularly blue-green algae blooms. We are also seeing more rainfall in the winter months, which has an impact in terms of runoff and nutrient inputs from rural and urban landscapes. As you can see on the top graph, showing annual measured and modeled precipitation for Midland, rainfall amount is expected to increase in the future, and as shown on the bottom graph, heavy precipitation events are forecasted to rise as well. Switching gears to look at trends in climate impacts on lakes, we'll start with ice cover and phenology, which is just a fancy word meaning timing. Across Lake Huron, there has been a decrease in the maximum annual ice cover as shown in the top graph, and more locally, ice phenology, or when the ice forms and breaks up, is changing. The longest dataset we have in the Severn Sound area is for Lake Couchiching ice out, which has shown a shift to earlier ice breakup in the spring. You can see on the bottom graph that there is a lot of variability from year to year, but on average the ice goes out about 5 days earlier than it did 100 years ago. For lakes of all sizes, the length of the ice cover season influences water balance and water levels, and also the potential for erosion during times when ice is not protecting the shoreline. A shorter ice cover season also means a longer growing season for aquatic plants and algae. In future, we expect a decrease in ice cover and gradual shortening of the ice cover season. Taking a look at changes we're seeing in algae in Severn Sound, we know that warmer and calmer waters favor blue-green algae growth, and this type of algae has the potential to produce toxins or cause taste and odor issues in drinking water. In the open waters, we've observed an increasing presence of blue-green algae late in the season, which you can see on the bar charts on the left showing seasonal algae biomass. The colors represent different classes of algae, and the one to focus in on is the blue-green algae, also called cyanobacteria. This shift in dominance is occurring despite long-term reductions and more recent plateaus in phosphorus concentrations, shown in the graph below. There is more research looking at the role of nitrogen in blue-green algae bloom formation, and we know that nitrate concentrations are rising in parts of Severn Sound, so there is likely more to the story here. The frequency of algae blooms is expected to increase with rising water temperatures, and with more frequent and intense storm and drought cycles. Climate has a huge impact on the water level story, and there are a couple of things I want to point out as they relate to the climate drivers that we've talked about. While strong wind events cause short-term fluctuations, the longer-term changes in water levels are due to Great Lakes Basin scale changes in factors affecting the water balance, namely precipitation and evaporation, which have links to air temperature, wind speed, and ice cover. The graph here shows seasonal water levels from the gauge in Midland, which was installed in 2009 through a partnership between SSEA, the town of Midland, and the Canadian Hydrographic Service. You can see where we currently sit in 2021, which is thankfully lower than the highs seen in 2019 and 2020. The impacts of high and low water levels vary depending on the shoreline area and range from flooding and erosion to habitat gain or loss and property damage. The shifts between extremes are projected to occur more rapidly, as we recently saw in the nearly 3-meter swing between the record lows in 2012 and record highs in 2020, only 8 short years, and the difference between these highs and lows is projected to rise. These trends and projections may seem pretty doom and gloom, but there are ways you can take action to protect your property if you're lucky enough to have a place on the lake, and to protect the lake regardless of where you live. On the waterfront, it's important to think about how you can invest in resilient shorelines using nature-based solutions. You might also hear this referred to as bioengineering, soft engineering, or green infrastructure. We essentially want to use natural systems to help reinforce the shoreline and absorb as much wave energy and runoff as possible. If you have the opportunity and means, it's also important to start thinking about relocating vulnerable infrastructure away from the shoreline, such as septic systems or wells. We need to get serious about reducing nutrient inputs and carbon emissions, and I encourage you to check out the resources on both of our websites. You can also calculate your carbon footprint using the tool developed by Georgian Bay Biosphere Reserve, which is unique in that it takes emissions from recreational vehicles and boats into account. Learn how to spot and report harmful algae. We have a great video on this on our YouTube channel, along with identification tips and resources on our website. Finally, I would encourage you to report the things you're observing on the landscape through one of our citizen science programs. If you're outside the Severn Sound watershed, there are programs run by other agencies that I encourage you to check out. The more we know about impacts that are occurring, the better we can manage them. To conclude, there are climate impacts on lakes through many different and often interacting processes that act at basin-wide and local scales. Major climate drivers include temperature, wind, and precipitation, and to quote David Phillips from Environment and Climate Change Canada, future projections predict the climate in our region to be warmer, wetter, and wilder. Local effects that have been observed include reduced ice cover and shorter ice season, increased algae growth in some areas or increasing dominance by blue-green algae, and increasing variability in both short and long-term water level fluctuations. It will likely be necessary to reduce nutrient inputs even further in this warmer and stormier world in order to reduce nuisance and harmful algae growth, and we will need to adapt and mitigate against climate impacts by making shorelines more resilient and reducing both emissions and nutrient inputs. I'd like to acknowledge the critical support we receive from our municipal partners across the Severn Sound watershed, and also from the Ministry of Environment, Conservation and Parks, who provide lab support for our water quality monitoring programs, along with all of the fantastic SSEA staff, both past and present. Thanks for listening, and I encourage you to follow us on social media and check out the resources that we have both on our website and our YouTube channel.